ケビン。それでは、日本時間の5時になりましたので、本日のウェビナーを開始させていただきます。It's 5 p.m. Japan time now, so let me kick off today's webinar. 本日は大変多くの皆様にご参加いただきまして誠にありがとうございます。本日進行を務めさせていただきます、スコットランド国際開発庁宮北と申します。どうぞよろしくお願いいたします。Thank you so much for joining us today. We are very pleased to have so many people at today's webinar. I'm yukiyo.miyakita, Scottish Development International, based in Japan. I'm going to be the MC for today's webinar. 本日のウェビナーは同時通訳をご利用いただけます。各スコットランド企業によるプレゼンテーションは英語でのプレゼンテーションとなります。日本語でのご視聴をご希望の方は、画面の下の方にあります言語のアイコンをクリックしていただきまして、日本語をお選びくださいますようお願いいたします。At today's webinar, a simultaneous translation is available. So please select your preferred language from the language icon in the bottom of the screen. 本日の流れですが、この後、スコットランド企業4社によるプレゼンテーションを各社10分ずつ行います。順番はフローテーションエナジー社、ブライドン・ベカルト社、モーティブ・オフショア社、バルモーラ社の順になります。After this short introduction, 4 Scottish companies are going to make presentations for about 10 minutes per company. The order of the presentation is Flotation Energy, Bridon-Bekaert, Motive Offshore, and Balmoral. 質疑応答の時間は4社のプレゼンテーションが終わった後、まとめてお時間を取りたいと思います。ご質問はチャットボックスもしくは Q&A のボックスにご記入くださいますようお願いいたします。ウェビナー中いつでもご記入いただいて構いません。ご質問がどの企業宛ての質問かを合わせてご記入いただけますと大変助かります。We will have Q&A session after the 4 presentations.So please put your questions in the chat box or Q&A box. You can put your questions anytime during the webinar. Please mention which company your question is addressing to. Kevin, can you please go to the next slide, please? Thank you. And next slides, please. Thank you.各企業のプレゼンテーションに入ります前に、私の方から非常に簡単ではありますが、スコットランドの洋上風力発電の概要につきましてご紹介させていただきます。Before moving on to the company presentations, I'd like to briefly introduce the overview of the offshore wind in Scotland in Japanese. 皆様ご存知の通り、スコットランドは英国北部に位置しておりまして、石油ガス産業の蓄積のある北海に面しております。英国や日本など多くの国が2050年までの脱炭素化、ネットゼロカーボンを目標に掲げておりますが、スコットランドは英国の目標よりも5年前倒しの2045年までのネットゼロを目標として公表しております。ヨーロッパの風力リソースの約 25% がスコットランドにあるとされておりまして、その風況を生かして2045年ネットゼロに向けた主な具体策となっているのが洋上風力発電です。2030年までに11ギガワットの設備容量を目指すことを公表しておりますが、現在計画中のものを含め、すでに 9.4 ギガワットの設備容量、また昨年より入札が開始されましたスコットウィンドリーシングラウンドでは、ラウンド1だけで約8から10ギガワットの設備容量となることが見込まれております。水深が60メートルを超える海域が多いため、浮体式のプロジェクトが増えていくことが同じく見込まれております。日本企業の皆様にもよく知られていると思われますビアトリス洋上風力発電所、あるいはモレイースト洋上風力発電所など、現在スコットランドには計画中のものを含め14カ所の洋上風力発電所がございます。また特徴としまして、世界初の商用浮体式洋上風力発電所でありますハイウィンド、世界最大規模となる予定のキンカーダイン浮体式洋上風力発電所など、 スコットランドには浮体式洋上風力発電の知見・経験が多く蓄積されております。長年の北海油田における50年以上の石油ガス産業の経験を生かしまして、大規模な洋上風力発電所の開発、オペレーション、メンテナンスなど、サポートをするサプライチェーン企業がスコットランドには数多く存在しております。本日ご紹介いたしますのは、そのうちの4社だけとはなりますが、いずれの企業も英国、欧州における洋上風力発電での豊富な経験を持つ企業です。本日のプレゼンテーションが今後日本における洋上風力発電産業の発展に向けて有益な情報になりますことを願っております。それでは各社のプレゼンテーションに移りたいと思います。最初にご紹介するのはFlotation Energy 社となります。Now I'd like to move on to the company presentations. So the first company is Flotation Energy. So I'd like to hand over to Tim.
Good afternoon. Thank you, Yukiyo, for the introduction. Konnichiwa. My name is Tim Sawyer. I'm Director of Flotation Energy, a UK specialist offshore wind developer. I'm going to take a few minutes of your time to talk about flotation, what it is that we do, and some of the projects we've been involved in that give you an example of what we do and show some real progress in Scotland and the UK in both bottom fixed and floating offshore wind. Next slide, please. Flotation Energy was formed in 2018 by its founders, Lord Nicholl Stephen and Alan McCaskill. It was formed to target UK offshore wind leasing rounds, the energy transition, that is helping oil and gas companies to transition to renewables and to develop international projects. We're master in floating offshore wind. We are very much capable in bottom fixed offshore wind as well, and I'll come back onto that shortly. We have a world-class expertise and distinguished track record. Between the principals, the directors, we've developed over 3 gigawatts of bottom fixed offshore wind in the UK. And some of the photos you can see on your screen, the top photo is the Beatrice offshore wind demonstrator, which was a 2-turbine, 10 megawatt project back in 2007, which was led by Alan McCaskill. And at the time was the largest turbines, offshore turbines, the deepest water, the first on jacket structures, the furthest offshore, and indeed the first to provide power back to an oil and gas platform. So very much a very challenging project, and that describes what Flotation Energy are about. That project has subsequently grown to be the Beatrice offshore wind farm, the middle photo there, which is a 588 megawatt bottom fixed offshore wind farm, again developed in the early stages by the Flotation team. On the right, you can see one of the turbines of the Kincardine floating offshore wind project, which was a small 2 megawatt machine. That now has been replaced by a much larger 9.5 megawatt machine, which I'll come back onto later. So we've got a very good track record. We're pioneering in the energy transition. We're working with oil and gas companies to bring in offshore wind to decarbonize their business, and I'll talk about that shortly. We have over 10 gigawatts of projects in the pipeline across the world, mainly in the UK, Japan, Taiwan, and Australia. And we've recently recruited into our team in Japan, Nobu Suzuki, who's on the call now, and I'll provide contact details for Flotation Energy at the end. Next slide, please. Flotation Energy developed the Kincardine offshore floating wind project, or the directors of Flotation Energy did, and the rest of the team were involved in developing that project and getting the consents and bringing it to the construction phase, which is where it is now. That was first started by Alan McCaskill and Nicholl Stephen, and they subsequently then brought Cobra in as a joint venture partner, who are part of the ACS group, a Spanish engineering, procurement and construction company. Combined, they've now brought that to the construction stage, and the photo you see before you is of one of the 9.5 megawatt floating turbines being towed to the site off Scotland. It's about 15 kilometers offshore in 60 to 80 meters of water. The total capacity of the project is 50 megawatts, which makes it the world's largest floating offshore wind farm and is likely to be the largest grid-connected floating offshore wind farm potentially to 2025-26. There's 5 9.5 megawatt MHI Vestas machines and the 1 2 megawatt machine. The 2 megawatt machine was installed in the summer of 2018 and has been generating since. It's now into port for refurbishment before being put out. There are 2 9.5 megawatt machines on the site, floating machines at the Kincardine site now. The other 3 machines are in assembly and will be installed by June this year when the project is fully complete and operational. So that's a hugely exciting project, one led by the Flotation Energy team, and really represents the culmination of a lot of knowledge around floating offshore wind, and most importantly gives us the lessons learned from that project and how we will do the next project, including in Japan. And we're very much keen to bring all that experience and the bottom fixed wind experience into Japan and work with our partners there. Next project, next slide, please. So Flotation Energy has 3 areas of business: UK leasing rounds, which are round 4, which has just concluded, and I'll tell you a little more shortly. That covered England and Wales bottom fixed offshore wind farms, and ScotWind, which is primarily focused on commercial floating. The second area is the oil and gas decarbonisation, the energy transition as we call it, and we have a number of projects going on in the UK and internationally. And we see an opportunity in Japan for oil and gas businesses wanting to get into offshore wind and working with flotation to develop those projects. And then in leveraging all of that UK experience and exporting that abroad. So we have a number of international projects in development, which is what I lead. And they include in Japan, where we now have offices and personnel, Taiwan with Reggie Wu, who I believe is on the call, in Australia, where I am based, and in Ireland and Norway as well. Next slide, please. So on the UK leasing rounds, the big news from us, which is hugely exciting, really very exciting, is that we won a 480 megawatt bottom fixed offshore wind farm in the Eastern RSC. You can see on the map there, it's labeled Flotation Energy. That was developed by Flotation and will continue to be developed by Flotation in a joint venture again with ACS Cobra. So we've formed a very good, strong bond with Cobra for these projects. It's in what we call Morecambe Bay. And you can see also on that map the other winners of round 4, which was a bidding round through the Crown Estate to bid for options for seabed leases. BP and Total, big oil and gas companies, European oil and gas majors, bidding very high to win acreage, to win seabed rights in the UK, to decarbonise their business. In the RSC, they are around our site. We picked this site very, very carefully. We decided where we thought was a viable location, which also drew on our strengths. And that was in amongst oil and gas assets owned by Spirit Energy. And we're working with Spirit now to both provide power to some of those oil and gas platforms, but also potentially to reuse as well. Can we just go down 2 slides, please? Thank you. And then you see Total on the other side of the UK and RWE as winners as well. So very, very exciting project for us to be winning, and combined with Kincardine, it really sort of brings about all the expertise we have in both bottom fixed and floating. Next slide, please. So I've given you a sense of what we do. In addition to all of that, we have a major 300 megawatt floating wind project in the UK that we're working with a large international oil and gas company on developing, and I hope to be able to give you some more news on that now. We have Nobu Suzuki, who represents the company in Japan. We've done a lot of work identifying sites, potential projects. We bring a unique experience and track record from the UK into Japan and throughout Asia. Our business model is very much a collaborative and partnership-based approach. We believe that project development is a domestic business, is a local business. You can't do that from outside Japan. So we're looking for partners to help us develop those projects, those who want to be part of floating offshore wind, and we're ready to receive you, to talk to you. We're active in UK leasing rounds, as I've just outlined. We've been awarded a 480 megawatt offshore wind project in the RSC. We're bidding on ScotWind, which is again floating wind projects. We are pioneering the energy transition with the first 300 megawatt floating energy project, which we hope to announce very soon in the North Sea, that builds on that Kincardine project. And we're developing projects in Europe, Australia, Taiwan, and indeed Japan. So with a lot of expertise, a lot of knowledge, we're very, very keen on developing floating offshore wind in Japan earlier, and we believe that's really important. Floating wind is at a relatively early stage. There's maybe 74 megawatts of installed capacity worldwide. Huge potential, gigawatt potential. We believe Japan is really well placed for floating, and we'd like to see projects developing much earlier, so we can bring those forward and provide all those benefits, industrial benefits, jobs to Japan, and indeed to create an export market as well. Thank you very much for your time. I'll be more than happy to take any questions. Arigato. And next slide, please. There's contact details for the company, myself, Nicol Stephen, and Nobu Suzuki in Japan as well. We'd be very happy to talk to you.
Thank you very much, Tim. So, ありがとうございました。初めにも申し上げましたが、質疑応答の時間は、4社のプレゼンテーションが終わりました後にまとめて取りたいと思います。ご質問は、今でも、チャットボックスもしくは Q&A の、箇所にご記入いただきましたら、質疑応答の時間に回答をさせていただきたいと思います。So now we would like to move on to the next speaker. So the next company is Bridon-Bekaert. So can I hand over to Greg?
Good afternoon. My name is Greg Morzgoy. I'm the Business Development Manager at Bridon-Bekaert Ropes Group. Today I'll be giving you a brief introduction about our company and some of our products that we are currently targeting at the floating offshore wind market. Go down a slide, please. Here we go. So BBRG was formed out of a merger in 2016 between the Bridon Group and Bekaert. The Bridon Group being a long-lived British rope company specializing in both steel wire as well as fiber ropes, and the Bekaert Group, which is a Belgian conglomerate of primarily wire products. Both companies began producing in the late 1800s. And we're producing steel wire ropes by the early 1900s. So we've been at this for a while with over 300 years of combined expertise in our respective industries. As the companies grew, they've both been on the leading edge in terms of product development with a number of innovations such as die-form steel wire ropes, Bristar wire rope with extruded polymer cores, etc. And this was done by heavy investment in R&D, and for example, in 2013, opening up our BB Tech Center specifically to develop next generation rope technology here in the UK. Currently, as an example of that, we have ongoing developments in hybrid rope technology. So basically taking our two expertises, which is synthetic fiber ropes and steel wire ropes, and trying to create combinations thereof, offering the benefits of both steel and synthetic. So as part of Bekaert, Bridon is about 10% of the Bekaert Group. The Bekaert Group itself is a very, very well-funded, globally dominant player in the wire business. 5 billion euros in sales, 120 countries we have footprint in with over 30,000 employees. So BBRG is a capable partner, well funded to be able to deliver on large capital projects on time. We do this through a global presence with offices, with production facilities, and with technical centers spread among all continents with the exception of Africa and Antarctica at this time. So 20 sales offices, 17 production plants, and 4 modern technology centers. So in all key markets of floating wind, whether we're looking at Japan, the UK, Spain, Norway, we have in-house engineering to support your project needs, as well as production capability. And being part of such a large experienced team, we're also ready to be able to establish new production facilities as needed. Bekaert on a whole is committed to floating wind, not just with regards to mooring lines, which I'll be discussing further, but with regards to a number of other products within our company portfolio. So we have advanced concrete reinforcement with our Dromix product. We have low loss cable armoring from Bekaert Solutions. We produce cords, reinforcing cords for tires and belts, for example, used for adjusting the pitch on rotor blades. And we have a JV with Epic Wires, developing a superconducting wire. So as I mentioned, this is done through a commitment to innovation. In our multiple R&D centers, we've committed to spending over 65 million euro in-house R&D per annum to be able to stay on the forefront and develop the next generation of products capable of enabling the green energy transition. Specifically with regards to ropes and cables, we have a center in England called BB Tech, which is one of the most advanced full-scale testing facilities in the world for testing of synthetic fiber ropes, hybrid ropes, and steel wire ropes. We have a range of instruments and test machines specifically targeted at looking at wear modes of ropes in use. We have forensic laboratories to determine cause of failure, and over 25 technologists working specifically in the advancement of rope technology. With regards to our mooring line production, currently this all takes place in the UK. So we have 3 facilities dedicated to the production of mooring lines. 2 of them are fiber rope production facilities, and they're both based up in Scotland. One of them in Coatbridge, which is close to Glasgow, is kind of our flagship facility for fiber rope production. We've also recently opened a second facility that's currently undergoing some expansion in Grangemouth, so on the east coast of Scotland, closer to Edinburgh. This is a second facility that's been purpose-built for mooring line production, as it has quayside access to be able to rapidly deliver large quantities of mooring lines. Finally, down in Newcastle, in England, we have our third facility, which is our third facility specifically for mooring lines, which is where we produce our steel spiral strand mooring lines. And this facility is vertically integrated with our Doncaster wire drawing mill that feeds the Newcastle facility as well as other facilities. So we are well positioned currently to produce mooring lines to meet the needs of the European market, as well as export needs to places like Japan. But as I mentioned earlier, we do stand ready to grow and expand our facilities as needed, because as we all know, the demand is growing in both Europe and in Asia, as well as elsewhere in the world, hopefully. And so the ability for the supply chain to quickly respond to the needs of such large numbers of lines as required as these farms go commercial is going to be key to success, we believe. Next slide, please. In terms of track record, of course, it's difficult to point too much at a long track record in floating offshore wind because it's rather new. But what we can do is we can point to a unrivaled track record in deep water oil and gas mooring. So if we look at a lot of what has become kind of the technological evolution leading towards floating offshore wind, it's natural to look at mooring for oil and gas. And BBRG has a very, very long track record in providing station keeping mooring lines for oil and gas, with over 2,000 meters installed to date around the world. of both steel wire and fiber rope solutions. And this comes with a tradition of pushing the envelope with a number of firsts. So first synthetic mooring lines, deepest spars moored in the Gulf of Mexico, et cetera, et cetera. So leading the way in terms of mooring is something we're accustomed to doing, and we are anticipating to do in floating wind as well. And thus, next slide, please. And thus we have been active in pushing that envelope in floating wind as well, in terms of getting floaters in the water using our mooring lines. So we currently have 2 floaters going into the water with, actually one in the water and one about to go in the water, utilizing our nylon mooring lines. One of them being the spar going in Goto Bay, Japan, with Toda Corporation. We also supplied steel spiral strand for High Wind Tampen in Norway, and nylon moor line for the Inner Ocean project off of Spain. So we're positioning ourselves well with regards to these demo projects to prove the viability of both synthetic and steel mooring lines, but particularly synthetic mooring lines, and our vision for what those should look like and how they are different than the mooring lines used in deep water oil and gas. We're also advancing the technology through JIPs. We've been a member of a number of key JIPs that are responsible for characterizing and proving the validity of these new designs as safe and economical for farm scale. Next slide, please. While I did mention that we've spent a lot of our time in oil and gas, and there's a lot of similarities between oil and gas mooring and floating wind mooring, it's certainly a completely different challenge, and it's very, very important for designers and installers and owners of these farms to recognize that we cannot simply take oil and gas technology and transfer them directly into floating wind. The requirements are very, very different given both the economics of the projects as well as the technical details. One of the key differences, of course, is water depth. If we look at the development of synthetic mooring, for example, in deep water, it was driven by primarily deep depths and the weight savings that could be realized by removing weight from the mooring line. In terms of floating offshore wind, this is simply not the case. We're looking at typically about 100 meters of water depth. And so the weight savings is not necessarily the primary driver for the mooring system. Additionally, having such shallow water depths and short mooring lines means that the dynamics, the loads on the lines are much, much larger, both because of the high wind loads that are naturally wanted on a floating wind turbine, but also wind wave load, and because the mooring line itself being shorter is now a less compliant spring. So this has really forced designers of these early demonstrators to rely on catenary or heavy chain or clump weights in order to be able to add compliance back into the line. We believe we can also solve the compliance issue in the lines itself by utilizing the proper materials and the proper construction to reduce the amount of catenary needed or eliminate it entirely. Another big difference is, of course, is the number of lines per project. We're talking, hundreds of lines and anchors and all associated hardware in one of these fields, one of these commercial farms, which far exceeds anything you would see in a typical oil and gas platform. So this also leads to the major economic problem, which is that the moorings do drive, there are a major driver of the cost of field development. So anything we can do to help make that more economical is helpful, of course. We also recognize there are many other technical hurdles, such as marine fouling. Again, since we're in shallow water, a large percentage of or nearly all the line will now be in the marine growth zone. There is opportunities for touching the sea floor. How do we mitigate the possibility of damage? How do we avoid the damage from vessels transiting in and around these dense farms? And of course, much lower system redundancy. So as you can see, there's a number of challenges we're working to address, why we have been working on projects to develop floating wind specific mooring lines that we'd be happy to talk to individuals about in more detail. Next slide. In terms of our current offerings of mooring lines, we do offer the gamut from steel spiral through polyester, nylon, and high modulus synthetics. Of the products that are out there currently being used in mooring, the only thing we do not offer is chain. One important note when we do look at ropes is that for those not necessarily thinking about rope all day, very familiar with rope, the material selection that we do have available in rope means we have a very, very wide range of physical properties, which perhaps is not necessarily appreciated when one is looking at one grade of steel or another. If we compare across the range, for example, in terms of elongation of failure, we have a tenfold order of or a tenfold difference from the elongation of, say, steel spiral strand or high modulus synthetic all the way out to a nylon rope, where with a typical nylon rope, you might be able to achieve 20% or more elongation, polyester about 10%, and the high modulus synthetics and the steels down in the 2 or 3% range. So simply in the amount of compliance, elastic compliance that one of these lines can put into the system, you have a huge leverage in terms of your design of just by the choice of the correct mooring line. They also have different behaviors in terms of fatigue, in terms of strength, density, etc. So we do believe in the approach of the right tool for the job, looking at things like steel spiral strand and high modulus synthetics for those applications where that high stiffness is important. So, for example, TLPs. We do believe that polyester still has a home in deep water, but ultimately what we believe is that in the shallow water, in that sub 150 meter water, where the vast majority of the commercial floating farms are now being planned on being installed, we do believe that nylon is going to be the way to go. And we're working actively with a number of developers as well as classification societies to be able to validate and prove fit for purpose nylon permanent mooring lines. Just briefly, I do believe that currently most demo floaters have been, go back one slide, please. Most demo floaters today have been using a significant amount of chain, as I mentioned earlier. And this was done primarily for ease of getting a system into the water quickly. When stuck with what was currently available from the world of oil and gas, you had ready to go, you had polyester mooring lines designed for deep water, and you had chain. With regards to these shallow waters, of course, the need to have a compliant enough system to reduce dynamic loading drove people towards the use of chain. However, we just don't see how this is feasible in the long term. There's a significant economic challenge with using moorings that are consisting of large amounts of chain due to the increased cost, the increased length required. Additionally, if we look at the failure rates over the last 30 years in oil and gas of chain moorings, they have been significant. And again, as I mentioned earlier, with the reduced redundancy that most of these floating wind platforms are being designed with, a single mooring failure would render that turbine out of service for some period of time until repair could be made at best. At worst, you could have a cascading failures, which would lead to either loss of the floater or damage to other floaters. So we simply don't see how the reliability of chain going forward, unless major changes are made, is going to improve things. And of course, there's high installation cost. There's large scope and the seabed damage that's possible by having all this chain deployed on the seafloor. And of course, even simple logistics issues like port storage of large amounts of chain during the construction process or the installation process. Next slide, please. So our approach to floating offshore wind mooring with fiber is to take kind of a modular approach to it. As I mentioned, we have a selection of load-bearing cores, and this is basically establishing the base chassis of what the rope looks like and how it performs. So we have materials and designs that can be tailored to match the application. whether it's looking at strength per size, strength per cost, stiffness or compliance, or fatigue life. So how we go about this is we design our core to match the need. Then we add enhanced durability features. So we've developed, or we're currently developing and have samples in the water for next generation eco-friendly marine fouling prevention systems to prevent any possible damage or even significant increases in weight of mooring lines due to accumulation of marine growth. We've developed enhanced cut resistant covers to minimize any possible risk of damage, for example, by over trawling or contact with the seafloor, as well as enhanced protection to allow our mooring lines to go to the seafloor on a regular basis, either during installation and wet storage, or in the case of certain mooring designs, on the lee side, there is opportunities for lines to go slack and touch the seafloor. And we want to make sure that there's no damage taking place there. We also have modules to enhance design flexibility, such as integrated buoyancy and simplified tensioning mechanisms. And of course, we're working to assure the safe use throughout the life of the mooring by way of advanced modeling of line degradation, as well as monitoring systems. Next slide. So that's it for BBRG. We bring experience and innovation to the world of mooring lines, and we're ready to help you in Japan, in East Asia, develop your farms economically and safely. Thank you very much.
Thank you very much, Greg, for your presentation. ありがとうございました。ウェビナーの初めにもお伝えしましたが、本日は同時通訳がご利用いただけます。画面の言語ボタン、インタープリテーションのアイコンから、日本語もしくは英語を選んでお聞きいただくことができます。それでは次のプレゼンテーションに移りたいと思います。次はMotive Offshore 社になります。So next presentation is Motive Offshore. So I'd like to hand over to Eddie.
Hi, good afternoon all. Thank you for your time today. My name is Eddie Moore. I'm the director at Motive Offshore Group, and I would like to take this opportunity to give you an overview of our company, our focus on the offshore wind market, what we are doing in Asia at the moment, and finally our commitment to Japan in the coming years. Next slide, please. So Motive Offshore, we are the leading global solutions provider for the back deck and beyond. And what that means is that we are here to support our clients throughout the entire life cycle of their project. So we have facilities and divisions to support from project inception to completion. Next slide, please. We have multiple offices. We're a global company, and we have been established for the last 10 years. We have offices in the USA, an operational base in Houston. We have an operational base in Brazil. We have offices in the UK, Norway, the Netherlands. We have a regional base in the Middle East. And most recently, we have set up an offshore renewables hub in Taiwan, where we've been working for the last 3 years. Next slide, please. Our business comprises of 3 divisions. Motive Rentals is there to support our clients, predominantly vessel owners and EPCI clients, in delivering their projects with rental equipment. For the renewable sector, we focus on onshore and offshore cable handling equipment, cable lay packages, deck equipment spreads, and finally export cable pulling winches. So on the rental side of things, we focus around the subsea cable, how we can help with our clients with the cable in terms of the handling and lay of the cable, and finally to the pull into the beach. Our engineering division, we have the capacity to design and manufacture standard equipment. We also have a design and build service for bespoke engineering products, and we can also maintain and service client-owned equipment, whether that be hydraulic, electric, or mechanical equipment. And finally, we have our inspection division, and we offer fibre optic testing and jointing of subsea cables, wire rope inspection and testing, lifting gear inspection, and finally NDT. Next slide, please. So our latest developments around offshore wind and renewables technology is in 2019, we acquired a company called PumpTech. They specialise in cable testing and jointing, and we launched our cable testing division. Last year was a big year for us. 40% of our offshore activity was focused upon renewable energy projects around the world. And late last year, we acquired a company called Flowline Specialists. Flowline, they have 10 years experience working in renewables, in particular offshore renewables, and they've focused on cable handling equipment and lay equipment. Next slide, please. So what I'll do is I will go through 5 major areas where we support in offshore wind projects across the world. Our cable handling and lay solutions, export cable pull-in spreads, our fibre optic testing and jointing services, vessel inspection services, and finally wire rope management. Next slide, please. So for cable handling and lay solutions, we have equipment such as reel hub drive systems, tensioners, linear and bow cable engines, under rollers, subsea turntables and pallets, and associated ancillary equipment. All of our equipment is operated by our highly skilled operators and supervisors, which they travel on a global basis to support our clients within their projects. Next slide, please. This is a video of a recent cable lay for us, where we've supported our client by the handling and lay of the cable onto the seabed. If you can press play. So you'll see we have a reel spooler there spooling the cable through one of our tensioners. The cable is overboarded over an overboarding chute, and then it's deployed onto the seabed. You can see the head there going into the water. So we've supported our clients there with the equipment, the supervision, and the operating personnel to complete the project safely and on time and budget. Next slide, please. Our export cable pulling packages, they consist of high capacity pulling winches. For us to make sure that the project is carried out safely, we also have specialised load monitoring equipment, which is delivered along with the winches. Our winches are operated by our highly skilled winch operators and supervisor teams. And finally, for the pulling packages, our equipment is more plug and play. So you don't need a large amount of infrastructure to be able to deploy the winch and carry out the scope. All of the mobilization is carried out by our team, and we handle the entire process. Next slide. We also have fibre optic testing and jointing. So our teams can conduct OTDR testing, insulation testing, high resolution monitoring, fibre optic slicing, splicing, and jointing services. So this means that we're able to support our clients from the cable factory, onboard their own vessels. We're able to deploy the cable and to test it before we pull it into the beach. So it's a comprehensive solution that we do offer. Next slide. So we wanted to touch on our offshore wind activity in Asia. We've been supporting offshore wind in Asia for the last 2.5 years. We were proud to be one of the first EPCI support companies in the region, offering full turnkey solutions from the cable factory to the beach. Some of our highlights in the last couple of years, we were part of Taiwan's first commercial scale offshore wind project, where we conducted the export cable pull-ins for Formosa 1. We have also been working on the Yunlin project, which is one of Taiwan's largest offshore wind projects. Again, we've been supporting with the various export cable pull-ins, which have been acquired over the last 12 months. This year's an exciting year for us. We are working on Changhua, which is the first phase of a long-term project. And this is more where our integrated services are really supporting our clients. We're able to do the quayside cable transpooling at the factory, the cable factory in Korea. So we handle and spool the cable onto our clients' vessels. Then we are able to support them with the cable lay, providing the cable lay equipment and personnel. And then finally, our guys on the beach are able to operate our winches to do the export cable pulling. So it's a comprehensive service around the subsea cable that we're able to support our client with. And later this year, we also have Formosa 2, which is due to commence in about 3 weeks' time. We have guys on their way to Taiwan at the moment to go and support our client with that. Next slide, please. So finally, why Motive in Japan? What are we looking to do in Japan, and where can we support our clients? So we have a proven track record across the majority of European offshore wind projects, and that's been bolstered by the acquisition of Flowline Specialists in December last year. So we really are specialists in delivering a complete solution from the cable factory to the beach, in particular around subsea cables, their handling, testing and lay. Establishing our branch in Taiwan as a regional hub for offshore wind is going to be a significant part of our journey. It does mean that we are able to support Japan from Taiwan for the time being. We've already committed to over $3 million of rental equipment, which is currently in stock in Taichung in Taiwan, and it's available for use in offshore wind projects. We've been involved in all Taiwanese offshore wind projects to date. And for Japan, we are exploring local partnerships. A large part about our business is we are actively committed to adding value through in-country content. And it's very important to us that we establish relationships with local partners in Japan, whether that be clients or suppliers, and that we invest in the local area. So for us, our plan is to continue to drive into Japan, and I would like to think within the next 12 months we'll have a facility in Japan where we can support the local environment. Finally, we have a global team of project managers and specialist personnel who are there to oversee things and also develop local talent. So I think between our project managers, personnel, and our contacts we have locally, even in Taiwan, I think this will help us going forward. Next slide, please. So that's our business overall. We're keen to support in any way we can. We are also keen to look at any partnerships with potential partners in Japan. So as Kevin said, the presentations will be submitted to yourselves along with our contact details, and we're happy to help in any way we can. Thank you.
Thank you very much, AD。どうもありがとうございました。それでは本日最後の企業プレゼンテーションとなります。バルモラル社よりプレゼンテーションをしていただきたいと思います。So Ian, can I hand over to you?
Hi everyone, thank you very much for the opportunity to present to you today. My name is Ian Milne. I am the Global Sales Manager for the Renewables Market at Balmoral. I'll give you a couple of slides to show you about the company history and what we're now doing in the renewable market. We have been established now for over 40 years, and we still are a privately owned company. Our founder and chairman is the existing owner, and within the Balmoral group, we are made up of 5 different companies, which also includes industrial tanks, winches and deck equipment, and also fire suppression systems. We're headquartered in Aberdeen, and for any of you historians here today, you might know that the founding members of Mitsubishi was Mr. Thomas Blake Glover, who came from the same region as us. So we've got a long-standing history together. So we're headquartered in Aberdeen, and that's where our manufacturing happens. We have sales offices in Houston and also in Newcastle. Within Balmoral, there's about 300 people working for us, focusing in on the offshore exploration and renewable market. And we also have agents positioned globally within the key areas. This is a screenshot of our facility here in Aberdeen, where you can see everything basically. The yellow outline there is our facility in Aberdeen. So what are we traditionally known for? As some of the other presenters had touched on, the traditional energy exploration has been the core of Balmoral for many years. So everything below the sea line here is the products and solutions that we've been offering to the market, particularly in deep water, harsh environments. We are the market leaders of all things, buoyancy, protection systems, and insulated products. So a lot of this knowledge and expertise that we've attained over the 40 years is transferable into the renewable market. But as Greg alluded to earlier on from Bridon, that you do have to make some changes to the different environments that you're going to be in. So this is what we're doing in renewables now. So you'll see that for fixed offshore wind, we're providing the cable protection systems, taking all our knowledge of polyurethane, taking all our knowledge of subsea environments and the hydrodynamics that come with it, and making these into the products that protect cables for the longevity of a project. They can be used in monopiles, or they can be used on jackets with a J-tube setup. And if you look at the floating turbine here, a lot of the subsea construction work is very similar to what we've seen typically with FPSOs in the oil and gas market. So that knowledge, as I said earlier, we're transferring through into the renewable market. A lot of patented technologies that really aid with installation with a total cost of ownership company. So we look at the added value and how we can make the systems be installed for the duration. And we'll look at how we can get them installed efficiently and safely as well. So you'll see the buoyancy modules, tether systems, and also crossover protection there as well. So existing infrastructure that may be in place, whether it be pipelines or cables or umbilicals, we also have solutions there to make sure they're not breached or interfered with in any way during installations. So a wee summary there. You see that for fixed and floating offshore wind. So the cable protection systems, monopile and J-tube configurations, the bell mouth and ancillary items, distributed buoyancy modules, dynamic bend stiffeners, hold back tether systems, touchdown protection, and marine mooring buoys. So we've got a really significant part to play, whether it's fixed or floating. And the message from us is the early engagement piece. We don't look at supplying a product. We like to partner up, as some of the other presenters also mentioned, and really come together in ensuring that the correct solution is being provided. And it's not about the price of a widget. It's about making sure that it's a good system that's going to be there for the longevity of the project. A couple more details on our cable protection system for fixed wind, named the Balmoral Fiber Flex. It's a patented system, very uniquely constructed, using woven fibers, which that type of technology gives you a great improvement in axial tension, and also will control the axial elongation. So going back to our dynamic expertise, fixed offshore wind, the cables are in dynamic environments. When it's from the burial point into the monopile or J-tube, that cable is what is really, really exposed to the elements. And as Greg also mentioned from Bridon, that the shallower water has its own challenges, and the sea conditions will really move the cable, twist the cable in all sorts of ways. So this technology will protect that for the duration of the project. There's a very thin layer of polyurethane surrounding the fiber flex. So that gives a very good thermal performance. If your cable was in a fully enclosed polyurethane system, there's a fair chance there that the polyurethane is going to act like an oven. The cable's going to heat up, and the heat's got nowhere to go. So there's a risk of baking the cable. And due to this very thin layer of polyurethane, it actually gives very good thermal properties and performance throughout the lifeline of the project. For the jacket installations, we have the Balmoral Bellmouth. So this is a unique universal system that we've created. They'll have varying cable sizes, whether it's going to be for the export line or multiple different cable types within the offshore field. So that results in different cable protection sizes. So what this bell mouth does, it actually accommodates any of the sizes whatsoever. So that one unit can be used for the export line, for the inter-array cables, off of the one system. So that really aids with the installation, reduces the risk of poor coordination, and typically installed on the quay side on the jackets and then put offshore during the installation. Couple of information on the distributed buoyancy. You speak about the floating wind market, and it's one that Balmoral is very, very active in, and it's definitely much a target for us. Deep water for us is 5,000–6,000 meters, and deep water for floating wind is maybe 500 or 600 meters. But that still comes with its own challenges. But the technology that we have and the patents that we have as well, really aiding with installation, really ensuring that the best possible solution can be handled in the vessel, can be installed easily, and it's going to remain subsea. Right now, Balmoral has over 40,000 modules under the water around the globe, and they're all still there. That's not by luck, that's by engineering and technical excellence. Certification by API 17L, we actually sit on the board and we chair the API 17L meetings. So we have a great understanding of the certifications on that subsea product specialist group. Our Balmoral bend restrictors, another core product to us, made out of polyurethane. We have our own laboratory, so we're constantly looking at material, constantly looking at evolving, ensuring that the systems are going to be fit for purpose. We have taken this technology and we typically see that in maybe crossover protection, etc. Standard marine and subsea products. So whether it's ROV buoyancy, pennant wire mooring, or standard floats required for when uplift is needed, Balmoral have a suite of products and 40-year experience of supporting them. Our bend stiffeners, anything from a meter to 14 meters. Every one of the Balmoral monopile cable protection systems, we have a bend stiffener internal there. And then when it comes to floating wind, again, with the subsea construction being very similar to that of an FPSO, we have the bend stiffener where the inter-array cables will then connect to each turbine. And again, that's all taken in-house, utilizing polyurethane, the latest technology and the latest materials. Impact and abrasion protection for the touchdown systems there. So you see that the standard DuraGuard product of the Balmoral system. So that can be standard cable protection on the seabed from shore to the structure. A big part of what is at Balmoral's core is our engineering. I touched on it earlier. It's something that we really get involved with, and we go shoulder to shoulder and really go on the journey, and that added value and the value engineering, total cost of ownership piece. So we'll take all the soil data, the met ocean data, the geotechnical information, and we'll run hydrodynamic analysis. We're going to do the 1 in 100-year storms. We're going to ensure that the CPS is going to remain and perform. We're not going to breach MBR. We're not going to breach any of the fatigue properties within the cable. And our system will be there suited for that. We'll also look at how we can make the system more cost effective. We'll work with yourselves, we'll work with the installation contractor, the developers. Can you bury closer? Can you put the scour protection after the cable has been installed? Things like that, which can then reduce the system length, which can then reduce the overall cost of the actual system. And given the fact that we also have our own research and development team, we do a lot of design engineering. It's not often we say we can't do it. It's we can do anything you want at Balmoral. We have our Balmoral testing facility. So this is a new testing tower that was installed about 18 months ago. And this was taken on the one sunny day in Aberdeen it was last year. But that's for doing the kind of full scale pool-in testing. So we'll replicate how the system will pull the string together, and we'll replicate a pool-in as you would see offshore, as best you can in a dry land environment. So it's a 20-meter tower. And what we do is we can actually vary the entry heights to literally replicate the monopile positioning of the apertures. Or we can install as you'll see there in the middle picture, we can install a J-tube configuration where we'll have our Balmoral bellmouth, and then we'll pull all that together. All data is captured and logged. And then what's very good about this is the added training. The offshore personnel from the installation contractors will physically get to put hands on the system and physically be able to pull this in and work together there. Touching on the laboratory, that forms part of our subsea test center. We would have the largest subsea test center privately owned in Europe. So we do full hydrostatic pressure testing. We've got 23 different vessels in total. So we can do full scale pressure testing for buoyancy or all different types of materials. So again, we're very big in ensuring that the technicalities and the longevity of the project, nothing leaves Balmoral without it being signed off. We really take that as a core of our business, ensuring the products are fit for purpose and they can be there until the end of the project. We recently completed through the Offshore Renewable Energy Catapult. So the ORE Catapult, they've it's like a government-led organisation within the UK to help with the energy transition and helping companies maybe typically seen in one sector moving into the offshore renewable market. So they've created this Fit for Offshore Renewable campaign, which is about a year's worth of solid work, and it's about business improvement, understanding of the market, the risks. So we've recently completed that. We got our certification there of our granted status. There's quite a big steering group, like the Vattenfall, they're involved, from the steering group level. So it's a very good opportunity there for Balmoral to demonstrate that our existing processes and procedures are really aligned, and small changes that we've made is that we can be fully recognised as not a renewable company or an oil and gas company, but an offshore energy company. And thank you for your attention. That's it from me. My contact details are there. The Japanese market's one very important to us, and we'll be very much looking forward to further dialogue when the opportunity arises. Thank you.
Thank you very much, Ian, and thank you to all the presenters for your great presentations. So now I would like to move on to the Q&A session. それではただいまより質疑応答の時間に移りたいと思います。冒頭にも述べましたが、質疑応答、ご質問はチャットボックスもしくは Q&A のボックスの方にご記入くださいますようお願いいたします。英語でも日本語でもどちらでも構いません。またすでにチャットボックス、Q&A ボックスの方にいくつか質問をいただいておりますが、いくつかはすでにスピーカーの方からご回答があるようです。So we would like to move on to the Q&A session. So firstly, please let me pick up some questions to Flotation Energy. So Tim, you have already answered some of the questions, but please let me read out some questions to you. So first question. So concerning anchor concepts for floating wind in APAC region, which concept, in your opinion, show most promise in Japan and Korea, respectively? Drag plate suction or dynamically penetrating anchors?
I think there are, well, going back a step, there are a variety of geohazards and seabed conditions around Japan, and they will drive whatever anchoring solution is chosen. Suction anchors, embedment anchors, micropiles, there are lots of options, and it's very much driven by seabed conditions. I said earlier, floating is at a relatively early stage. Anchoring technology is not. You've heard from some really good companies today, and it all very much depends on where the project is and those site conditions.
Thank you, Tim. And I think this question is also for you. So about gas to wire, about GTW, gas to wire, connecting to floating wind energy plant. We have GTW plant, gas to wire. have you had experience of FEED or pre-FEED of such GTW project?
We're looking at options for gas to wire, including with 2 oil and gas companies to be doing that. I wonder if that's maybe a question for one of the other speakers. I did read that and I assumed it was maybe someone else.
Okay, thank you. So, 改めまして、本日は同時通訳がご利用いただけますので、すべての質問、アンサーを日本語で、お聞きになりたい、皆様は、言語の、アイコンから日本語のチャンネルに、お切り替えくださいますようお願いいたします。Okay, so let me ask questions to Bridon-Bekaert. So Greg. So actually we've got a question in Japanese. So I'm going to read out the question in Japanese. So can you please switch to the language channel to English one, please?
Got it.
Okay.
Ready.
Okay. では、日本語で質問を読み上げさせていただきます。最後に係留ロープのモニタリングを行っているという説明が、ありましたが、どのようなセンサーおよびセンサープラットフォームでどれくらいの頻度でモニタリングを行っているのでしょうか。
There are currently several approaches we're taking towards the monitoring of mooring lines. There is simplest, of course, is just to be monitoring something like load at the end termination or overall elongation in the mooring line via position monitoring of the structure. Additionally, we have a joint venture which we're taking part in that is using vision-based inspection. So it would be a periodic inspection of the entire mooring line to look for damage, both superficial as well as internal damage that may be present in the mooring line. So in terms of frequency, that is something that would be done on a periodic basis because it would require intervention from an ROV or similar device. But the monitoring of, for example, tension state can be done continuously.
Thank you very much. ありがとうございました。グレッグ、他に質問がありますので、今度は、英語で聞けるよう、すいません、言語のチャンネルを元に戻していただけますでしょうか。私が英語で質問を読み上げます。Okay, so thank you very much for your presentation. It appears there's a production facility in Japan on the slide. Which kind of products are manufactured in Japan?
Yeah, that facility is a Bekaert facility. It's outside of the Bridon-Bekaert ropes group, which I'm a member of. So I honestly don't know exactly what is produced there currently, but I can look into it. If you would send me your email address in the chat box, I can look into it.
Thank you, Greg. And I'm sorry, but I have another question in Japanese. So again, can you please switch to Japanese to English channel?
Indeed. Go ahead.
Sorry. 係留ロープのモニタリングを行っているという説明がありましたが、どのようなセンサー、すみません、これはすでに質問したものでした。大変失礼いたしました。Sorry, Greg. I think you have already covered this question.
Okay.
Okay. So let me go on to the next question. So the question is to Eddie and Ian. So Motive Offshore and Balmoral. So
okay.
So let me read out. So will shorter distance from shore cause different challenges to the deployment of cables, or will the methods and procedures be based on the same experiences as Taiwan?
Okay, I can start first, Ian, if that's okay.
Please, Eddie, thank you.
So for our experience in Taiwan, the key issue that we faced in terms of shorter pools has been making sure that there's no damage to the local environment. Most of the cable pullings that we've done have had to be conducted underneath oyster farms, which has led to a few challenges. And typically what we're doing at the moment with our clients is a client construction vessel will be deploying the cable. And then there's a barge at the halfway point with one of our tensioners, which is operated to maintain the tension on the cable. And then our winch is on the beach, and the cable is pulled through HD ducting to make sure that there's no damage to the oyster farm. So that, I would say, that's the key challenge that we have with the shorter pullings, is making sure in Taiwan, making sure that the local environment there's to minimize any damage caused.
Yeah, and I guess on Balmoral's side and the protection systems, not really that much of a difference. Would be challenges maybe towards the shore side, where it is that bit more shallower, and the underwater currents and environment is quite, slightly more harsher. But the way the kind of wind farms have been set up and constructed, the products that we've got accounts for that. We allow for that in analysis and design time. So it would have maybe a bit more kind of engineering work, but it wouldn't really phase us, if you like, in terms of any sort of additional challenges that can't be overcome.
Thank you very much for your answer. So another question to Ian, Balmoral. So regarding submarine power cable installed for fixed foundation, fatigue due to repetitive vibration caused by sea current is often addressed by developers. I understand you touched on VIV analysis in the presentation, but do you have any product-based solution to restrict vibration?
Yeah, it's a great question. Thanks for asking that. Certainly, the Balmoral system and how it's constructed is very good in VIV anyway, with the size and the construction method of it. But I've seen through analysis that the VIV is causing us challenges. We do have a product that can actually be molded directly into the CPS. Our product's called LDV, but essentially it's been designed around a turtle shell, so the water can actually deflect through the shell, if you like, and really reduce that exposure to VIV. So certainly it's something that's within our product offering there for sure. Yeah. So as I said, the system's very good at low drag and vibration anyway. But I know that the environment, particularly around Taiwan and in Japan as well, is maybe slightly harsher to what's typically seen maybe in the likes of Europe, for example.
Thank you very much, Ian. ご質問の際は、可能な限り、どちらの企業宛ての質問かを合わせてご記入いただけますと大変助かります。So the next question. So I'm not sure which company this question is addressing to, but the question is concerning the challenges with cable laying and proximity to shore. Can we understand that there's even greater demand for cable flowing than deeper water? Also, with the present cable laying vessel fleet, be able to operate in shallow water conditions in Japan?
From my perspective, yes to the final part of that question. I think on the construction vessel side, providing that they have the required equipment, I think the sea state is acceptable for the work to be carried out there. On the trenching side of things, certainly in Taiwan, there have been more companies in the market which are doing mass flow excavation, such as Rotec and James Fisher. And the clearance and the trenching themselves, that's been a part of every project that we've taken part in Taiwan. So I would imagine It would be more for these guys to answer, the specialists in Rotec and James Fisher, as they have the experience. But I would imagine that yes, it will still need to be involved with the Japanese market.
Thank you very much. So the next question, and so we've got a question in Japanese. So can I ask all the presenters to switch to English language channel to understand the question? I'm going to read out the question in Japanese. And it's probably to Ian Balmoral. Okay, so let me read out in Japanese. ケーブルのメンテナンスにおける可視化についてですが、ROV の活用となると、ケーブルと ROV の、アンビリカルケーブルとトラブルが生じる可能性があります。その意味で ROV ではなく、AUV を使った検査とする可能性はございますでしょうか。
Yeah, I'll give that one a go. I think that's maybe more aligned to maybe with some of the marine contractors who actually have the vessels, etc. But yeah, I know that technology is actually getting trial tested just now, and off of the European Offshore Wind Deployment Centre in Aberdeen, which is basically the Aberdeen Bay wind farm. There, that's through the Ori catapult. There is some testing just now of using AUV opposed to ROV. So I know that technology is certainly on the market, and it's getting trial tested at the moment. But that's only my knowledge. I'm not an expert on the subsea part of that inspection.
Thank you, Ian. So I think some of you have already answered the questions, but let me pick up some questions which might be interesting to other participants as well. So firstly, let me pick up this question. So this question is to Flotation Energy. So Tim, you might be able to answer this question. So the question is, what are the technical challenges that will be different from Scotland you expect to face in building floating offshore farms in Japan?
A very good question with a very long answer. I think some of the key differences in site conditions, at least, are around geohazards. So seismic events and typhoons, they're not things we experience in the North Sea in the UK. So clearly that's an engineering challenge to understand that and to design solutions. Seismic events have lots of impacts on seabed mobility, which goes back to the previous question on anchoring technologies. Some would argue floating has more options to deal with seismic events. Time will tell on that front. I think some of the other technical challenges will be offshore wind is emerging in Japan. The expertise is growing over time, and really making sure that all the lessons learned from the UK and indeed Europe in offshore wind are brought over to Japan. The same mistakes aren't repeated. There's also a developing supply chain, and there's local content requirements in Japan, and be able to balance up local capabilities with imported expertise. And on that front with floating, I'd like to see floating wind really developing much quicker, so that expertise can be developed in Japan for a domestic market as well as export. There are differences in the way permitting and consenting is done. Policy needs to be in place for floating. There's a number of differences, and I think most of it really reflects that offshore wind is quite new to Japan, and the experience needs to grow. There's lots of other things I can pick up on that maybe some of the other panel can talk about as well, but that's a reasonable summary, I guess. And we've also got stakeholder concerns, fisheries in particular, shipping, not used to these sort of things, not used to how to deal with it.
Thank you very much, Tim. So can I ask Greg, Ian, and Eddie if you have any comments regarding technical challenges you're expecting to face in terms of floating offshore wind farms in Japan?
I think Tim hit the nail right on the head, but I would reiterate, with regards to technical challenges, of course, with floating, typhoon and seismic certainly are going to be a challenge in terms of system reliability, particularly with regards to maintaining the moorings. Furthermore, I agree also with the risks posed by high density marine traffic through the area, particularly with regards to fishing. So ensuring that we are not coming into contact with fishing vessels and other vessels is going to be very important from a reliability perspective.
Yeah, I'd probably add to that. I think from Balmoral's side, I don't think the technicalities really scare us. I think in the subsea environments, we've got the engineering, we've got the technical teams. We've worked in very similar environments, not Japan, but in other parts of the globe where similar kind of hazardous conditions take care of. And I noticed when Tim had said, you don't see that type of environments. Clearly, he's never stood in the north corner of Aberdeen in the middle of February. He'd be exposed to that quite often. But serious aside, though, the subsea construction in the terms of a model, that doesn't really scare us. I think a lot of it is going to be like you've kind of touched on, the fisheries, the shipping lines, and getting that kind of buy-in. And that similar kind of message has been seen in other parts of the globe as well. There's other countries with the same challenges. And I understand that the fishing industry within Japan is a very well established one. But if you look at the northeast of Scotland and if you look at Orkney and the islands here, that kind of transition in skill development and development from fishing people, it's through generation had fishing vessels, they've now actually diversified into the offshore renewable, offshore energy kind of world as well. So there's maybe a couple of challenges there culturally as well, yeah.
And from my perspective and Motive's perspective, I think where we've, again, looking at Taiwan, where the main issues that we've kind of, our challenges that we've faced is our clients have went in with high expectations and short deadlines in terms of project completion for construction. And the weather in particular, has caused significant delays for our clients and their clients. And I think, as the market is developing in Taiwan, there's a greater understanding of a realistic time frame for some of these projects. And in particular in the construction phase, if the weather does get, a bit more turbulent, from a safety perspective, work has to stop. And then there's the added on delays. So I think that's, that will be a challenge in Japan, just as it is in Taiwan, and be up to our clients to make sure that, they're giving their clients realistic expectations in terms of build schedules.
Okay, if I could just add a little bit to that. The other one with floating is we're obviously potentially dealing with very large floating structures. And the way those are fabricated locally will be a really interesting challenge. Certainly for Kincardine, and I think one of the lessons learned is we would build those foundations in a very different way, a modular design in smaller components that can be assembled locally, and that are also designed to suit available ports. There's not many very deep, big ports in the world that can support massive structures like that. So it's really for us to design solutions to meet what local ports can do and what local or rather maximize local fabrication capabilities. And by doing modular designs, you can then source those components worldwide and including Japan. So it's thinking about how we take what are pilot projects or demonstration projects into commercial projects and how we offer maximize local benefit and adapt to local conditions.
Thank you very much for your answers. So another question to Greg, Bridon-Bekaert. So what is the maximum diameter of the nylon, polyester, and high module synthetics in the experience?
Currently, our typical maximum size is around 300 millimeters in diameter. We have capability to go larger than that, to about 350 millimeters in diameter, but rarely is there a need for that right now. So typically, 300 would be the practical upper limit for synthetic mooring lines. In terms of what we're looking at right now for some of these floating structures, it's going to be 200 plus, so 200 to 300 millimeters is usually the size you're looking at for a low modulus cable.
Thank you very much, Greg. So the next question is to all 4 companies, and I'm going to read out in Japanese. So could you please switch to the language channel to English? Okay. それでは質問を読み上げさせていただきます。漠然とした質問にはなりますが、日本では地震の影響を考慮する必要があると思いますが、ルート部のケーブル単体への影響や基礎自体の影響評価の解析ノウハウは蓄積されているのでしょうか。Do you understand the question?
Yeah, I can go ahead and start with that. I think with regards to the effect of earthquakes on floating structures, it's really going to come down primarily to the anchor and the stability of the anchor. So, of course, the mooring line and the structure itself is going to be somewhat isolated from any of the events. Again, barring any sort of large wave. But I think it comes down primarily to the anchor. So at Bridon, we wouldn't be specifically involved in the anchor design, but we do work closely together with anchor designers, anchoring contractors, as well as mooring designers to do the analysis of what is the impact of a slippage of an anchor, for example, on the system integrity.
I'm happy to add my part to that, and maybe Ian and Eddie will be more qualified to speak on the technical aspects. Seismic events present a lot of challenges, but on cables and anchors, liquefaction, movement of the seabed is clearly a very key risk depending on site conditions, and a need to understand that to make sure the anchors stay in the right place in the first place, but also the cables that are laid on the seabed or even buried can cope with that kind of motion. Maybe Eddie or Ian can add something to that as well.
Yeah, I guess from our point, it's that anything's doable. I think it's more from our analysis team would be able to give you a more technical kind of response. But as much data that's physically possible of the environment can be there. We've got our analysis team in-house that then, in other projects just now, we've got our own analysis team. We work with the cable manufacturing analysis team. We also work with the installation contractor analysis team. So we're sharing that data and going back to that collaborative approach, to ensure that these things happen. But you're right, if the seabed moves, what happens to the cable? What happens to the anchor? So that needs to be accounted for and engineered at the upfront engineering side for sure.
And from my side, I can't really add much more than that. We are driven by our clients analysis team, as Ian mentioned. They are the installation team. So we're working with them to make sure that we are delivering our project within their parameters.
Thank you very much for your answers.
We'd be happy to arrange a discussion with whoever asked the question. We'd be happy to arrange I can get my analysis guys in a room and we can thrash it out if that was something to be carried on after the presentations.
Yeah, okay, thank you very much for your suggestion, Ian. And I'm sorry, we cannot cover all the questions. I'm conscious about time, so I'd like to now close the Q&A session. So I'd like to wrap up. お時間の関係でですね、お答えできていない質問もございますが、また後ほど E メールでご回答をさせていただければと思います。それでは最後に一つご案内をさせていただきたいと思います。 3月3日から5日にかけまして、東京ビッグサイト西展示棟で開催されます風力発電展ウィンドエクスポに、本日プレゼンテーションをしたスコットランド企業4社を含む英国企業11社が英国パビリオンとして出展する予定にしております。残念ながら来日ができないため、オンラインを通じた参加となりますが、オンラインを通じた面談も可能です。ご来場の予定がございます方は、ぜひ英国パビリオンにお立ち寄りいただけますと大変幸いです。また、私も会場におりますので、スコットランド企業へのさらなる質問など何かございましたら、お気軽にお声掛けくださいますようお願い申し上げます。それでは、これをもちまして、本日のウェビナーを終了させていただきます。皆様、長い時間お付き合いいただきまして誠にありがとうございました。So I'd like to close the webinar now. Thank you again for joining us today, and I look forward to seeing many of you at Wind Expo next week. Thank you very much.